So you are all welcome to this class, tensor and vector and tensor analysis. At the last class, we discussed about the operator. Today, we also continue from the operator. We discuss the chord, the divergence, the last class, and let's see how we're going to move forward from the del. Okay, let me quickly share the screen. Can you see my screen, please?
Yes, sir, but the screen is cutting. No?
Is public network, it will be okay for me. Just look at a good area to sit down. Are we all? Is it okay now?
No, it's not entirely okay. Good day, sir.
You are welcome.
Okay.
Can you see it now?
Yes.
So let's look at another example from where we stopped the last time. And this one is example 3. Let's continue from there. Example 4. Example 4 says, let's say if we want to look at the core. If A is equals to x z raised to power 3I minus 2x squared yz j plus 2yz4 k. Set find cross A, del cross A, or we call it core A. At the point 1, minus 1, 1. So let's look at the solution. Or have you solved this question before? I don't think so. We've not solved anything on core. Yes, divergence and the del. Okay, let's continue. And the gradients. So, how do we solve this problem, please? Recall that we have this cross A. It's the same thing as d dx I plus d dy j plus d dz k. Cross the entire question. X z cubed I minus 2s squared yz j plus 2y z raised to power 4 k. Or let me just draw this one. Plus 2y z raised to power 4k. So now we have this. Who can remind us what to do when you get to this point? When you are doing the cross. Yes, I'm waiting for us to talk. What do we do?
We'll take the matrix form.
To check the,
We'll put it in a matrix form.
we put it in a matrix form. Thank you. How do we put it in a matrix form? Remember the determinants I, J, and K. We have D, the X, with the first I will go to I. That is X, Z raised to power 3. Then D, the Y. D, the Y will go to I. Minus 2x squared YZ. Don't forget. And K, D, the Z. 2y z raised to power 4. So we take them one after the other. Don't forget plus, minus, plus. So after we've done this, let's pick I, component I. Where you pick the I we parallelize, the column will parallelize, the row will also parallelize. It will remain what? That is, this will go 0, the entire this one. Then the entire, all this one also goes 0. So what do we have left? We are having what?
J and K.
Yes, I'm waiting.
D dy
Okay.
minus
D
2x
X Z
yz d dz
Okay.
Sorry, Mark, getting in just ahead of phone. Stones will get there.
D dy ahead.
2 YZ power 4.
Minus 2x squared yz. D dz. 2y z raised to power 4. Minus j. Don't forget, if I said minus j, that means the entire, I'll pick j now. I pick j because negative is up. That's why. The entire row and column of j will parallelize. We have it to be what? D dx s cube. Then d dz. 2y z raised to power 4.
So it's tested across the front of that 50-yard area. There's been 3 or 4 where to step in. He's had to read.
Plus k. Our k, when you pick k now, what happened to k? So you have it to be what? D dx
Y.
S Z raised to power 3 d dy minus 2s squared y z. Are we right?
Yes.
Are we
sir.
together, please?
Yes, sir.
Okay. Now, what you need to do is this multiplied by this minus this multiplied by this. That's how you do it for each of them. So for I component, we have I component to be d dy of what? Of 2yz raised to power 4 minus d dz of minus 2x squared yz minus j d dx of 2y z raised to power 4 minus d dz of s z raised to power 3. Plus k d dx of minus 2x squared yz minus d dy of s z raised to power 3. Now let's do this one now. What do we have? You have to differentiate it according to the variable. The first one said d dy, meaning you are differentiating with respect to y. Am I right? Hello?
Yes, sir.
Okay,
Yes, sir.
let's
Yes, sir.
differentiate this with respect to y. What do we have?
2z raised to power
Raised to power what? 4.
raised to power of 4
Yes. No, you have minus here. Minus times minus.
plus
Differentiate this with respect to z.
2x square y.
Okay. When you differentiate this with respect to x, do you have x here? No, 0.
No,
With respect to z, you have minus 3x z squared plus k. Let's differentiate. If you differentiate this with respect to k, you have minus
minus 4
4x yz.
yz
This with respect to y, 0.
0.
So this is what we have. Then we can write it out accordingly, according to the components. So you are going to have 2z raised to power 4 plus 2x squared y I minus that's minus plus 3xz squared j minus 4xyzk. At what point? At point x equals to 1, y equals to minus 1, z equals to 1. So it's going to be what? 2 into 1 raised to power 4 plus 2 into 1 raised to power 2 and minus 1 of I plus 3 into 1 squared of j minus 4 into 1 minus 1 and 1 of k. So what do we have here? 2 plus 2. 2 minus 2. 0i plus 3j plus minus times minus
plus
4k. So the final answer will be, this will be your final answer. You can write it this way, or you write it in, say, 3j plus 4k. That's your final answer. Any question? I believe with what we did, you should be able to solve any question when it comes to this type of problem. We have already touched base all the values. One are the 3 operators, and those 3, these are the things they normally ask you in your work. So let's try as much as possible to lay our hands on. I see one of us open the. How many of us checked the past question? One of you uploaded the last time. Let's lay our hands on it and solve as many problems as possible before you enter the exam hall. I think that one will help us to be able to it will prepare you guys. Now let's look at another topic, vector integration. You know, we did the differentiation, and let's look at the integration aspect of it. The integration aspect of it, what does it say? And whereby we have a continuous. Let R of u equals to R1 of u I plus R2 of u j plus R3 of u k. Be a vector depending on a single scalar on a single scalar variable u, where R1 of u, R2 of u, R3 of u are supposed to be continuous. Continuous in a specified interval. Then integral of R of u du is the same thing as I integral of R of u, R1 of u du plus j integral of R2 of u du plus k integral of R of u du. So in this case now, we are talking about, it's called indefinite integral. And indefinite integral. What is indefinite integral, please, of R of U? Why do we call this one indefinite integral? Anybody? I believe you've done calculus before now. Yes. Should I call name? Saturday. Olalekan, Thomas, Olasukomi, Ahmed, Musa, Monday. So, can we look at it? So, we call it integral. We call it indefinite integral, remember, because there is no bound in between them. Remember when you have this A, B, this is a boundary. You have a boundary, you have an interval, you have a value. This is definite. We call this one a definite integral. Definite integral. But when we get there, you will know better. But indefinite, because there's no value, you don't have upper bound, you don't have any bound to substitute. But by the time we get to that place, you will see. So now, for example, let's look at this. If there exists a vector S of U such that R of U is the same thing as d du of S of U. Then how do we integrate this? So it simply means that integral of R of U du is the same thing as when you said d du, you are differentiating this of S of U du. So when you differentiate this, when you integrate this one, what do you have? By the time I integrate this one, it simply means I'm going to have S of U plus C, because it will cancel the integration is anti-differentiation. So it will cancel that. But now let's look at a definite cases. In the definite cases, you have it to be integral of AB, that is upper limit minus lower limit. It will be R of U du is going to be integral of AB of d du of S of U du. So let's integrate this one. It's going to be what? S of U plus C. C is just a constant, it will cancel out, but you can now substitute A and B here. So meaning the one on top, which is B, is our upper limit, the one below is our lower limit. So it's going to be, when I substitute it, anywhere I see U, substitute our U is A and B. It's between that. So it's going to be S of B minus S of A. So that's the solution. The solution says upper limit minus lower limit. But now let's look at the integral, line integral with respect to what we are doing. Line integral. We have line integral, we have surface integral, and we have volume integral. So I will just lay the foundation and solve one or two questions, then we call it a day. Okay, let's look at the line integral. For line integrals, we said let's R of u equals to S of u I plus Y of u j plus Z of UK, where our R of u is the position vector of S, Y, Z, defined a curve, C, joining points P1 and P2. Don't need to draw the diagram now. So at where our U is equals to U1 and U equals to U2 respectively. So if you have our function, we said let A of S, Y, Z equals to A1I plus A2J plus A3K. Then if you find the integral P1, P2 of A dr, is going to be integral of this closed integral C, because C means closed integral. A dr equals to integral of A dx, A1 dx plus A2 dy plus A3 dz. Remember, the R means what? This is our R, means dx, dy, dz. So if you leave it that way, so we have this. At the end of the day, if C is closed graph, is closed curve. If C is a closed curve, then we have integral of, this is the closed curve A dot dr to be in the closed curve A1 dx plus A2 dy plus A3 dz. So they normally use this particular equation and this particular line integral in aerodynamics or fluid mechanics. For those of us that want to specialize in fluid mechanics, you will use more of this. Then for the surface integral carry two things. Let me just give us the surface. Surface integrals. Under the surface integrals, we have, let's look at this diagram. So we call this one, let's say this one is N. This one, this X. Our S is in this here. We have this surface X. We have origin X, Z, and Y. So in this case now, we have this XYZ plane. Then if our the X, we have the X to be equals to N the X. If X the X is there, then when you have surface integral is always represented by double integral, then you have X here, which is this, that shows that it's a surface integral. The X dot D of this equals to a surface integral X A dot N dx. So let's take note of that. And from there, example of surface integrals is called the flux. The example is what we call the flux. The flux of A over X. The flux of A over X. So, but if it is closed also, we represent the closed integral by the closed surface integral with the notation will be integral, integral. Closed is used to indicate, anytime you were reading and you notice that indicates integration over the closed surface S. Closed surface X. Last but not the least, we have what we call volume integral. The one of volume integral, we consider the volume integral to consider a closed surface in enclosing a volume V. Then let's look at it. We have integral V, which is volume, represent volume, the A dV, which is, and we can also have it this way, dV. But now let's look at the examples of all these integrals that we've mentioned. And let's see how do we normally solve them, and what are the things do we need to take notes when you're solving them. Are we together?
Yes, sir.
Okay.
Yes,
sir.
Okay, let's look at example 1. Say that if R of U is equals to U minus U2 U squared I plus 2U raised to power 3 plus 3K. Please don't make that mistake. Don't say U minus U2, U squared is 0. They are not the same. Please take notes. The question has a find A integral of R of U du and B integral of 1 to 2 R of U du. So For us to solve this problem, integral of r of u du will be integral of the entire u, r of u, right? So it's going to be u minus u2 I plus 2u cubed plus 3k du. So what it simply means is component by component, don't forget this is j. Component by component. So how do we solve that? The component will be I integral of u minus u2 du plus j integral of 2u cubed du plus k integral of so integral of what? Integral of 3
du.
du. Okay, let's integrate them one after the other. I believe you still remember integration. Let me quickly digress and give us this. Integration says, if you have y equals to raised to power x raised to power n, they now ask you to integrate x raised to power n dx. What does it mean? You have to integrate, is going to be x raised to power n plus 1 over n plus 1, everything plus c. Do you still remember now?
Yes, sir.
So, if that is the case, so we need to integrate each of them. So let's solve them one by one. So for I now, we have u raised to power 2 over 2. You believe me?
Yes, sir.
Minus u raised to power 3 over 3 plus C1. Let's call this one C1. So, because C1, C2, C3, they are all constants. I plus two u raised to power 4 over 4 j plus three what? Who can tell us?
3u.
Thank you. Okay. So what do we have at the end of the day? We can collate all the C together. Whatever you have the C, they are all C. They are all single constants. So it's going to be u squared over 2 minus u cubed over 3 I plus 2 will have cancelled to it. Here 1, here 2. So you have 2 raised to u raised to power 4 over 2 j plus 3 u k. Everything plus c. Now, we can now use it to solve. That's equation 1 they want us to do. That's question A. To solve it. Because question A says, find integral of R of U. The same R of U, they now gave us to substitute the limit. So we don't need to pass through all this solution again. Just substitute the limit into final answer you have here. So it's going to be what? So it's going to implies U square over 2 minus U cube over 3I plus U raised to power 4 over 2J plus 3U K plus C or 1, 2. That's the volume. And that's the point where we're supposed to substitute. So you have to be careful at this point. You have to substitute it one by one. And minus, that is upper limit first, which is, that means you need to substitute 2 first. Let's substitute 2. It will be 2 raised to power 2 over 2 minus 2 raised to power 3 over 3 I plus U raised to power 4, which is 2 raised to power 4 over 2 J So what else do we have? Plus 3 into 2 K. Then plus C. Then upper limit minus lower limit minus anywhere you see U, substitute 1 now. 1 over 2 minus 1 over 3 I plus 1 over 2J plus 3 over 1 so plus 3 over 1 plus C. Don't forget this is K. Now let's handle it. What do we have for the first one? Here you are what? 4 over 2 minus 8 over 3. What do you have where you add it together? Four raised, 2 raised to power 4 is what, please? Anybody? 2 raised to power 4 is what?
16.
10.
16.
Ah,
16.
is 16. 16 divided by 2.
8.
So if you look at the other side, the minus will affect the other side. But let me open it. Okay, let's resolve this one. What do you have for this? 1 over 2 minus 1 over 3. The answer is what? Nobody? What's the answer, please? Look at it. 1 over 2 minus 1 over 3. 6. How many 2 here? 3.
1 over 6.
1 over 6. This will be 1 over 6I. I've opened the negative. So when you see the negative, it's multiplying them now. Minus 1 over 2j minus 3k minus c. You see this c, we cancel this c. So that one is gone. Then we need to now add everything according to components. So here you have, what do we have here? 4 over 2 minus 8 over 3. This is c. 3 times 4, 12. Minus what? 2 times 8, 16. What's the final answer, please?
Minus 2 over 3.
Minus 2 over 3. Thank you. So you have minus 2 over 3i. Take the other I from here to join. Minus 1 over 6i. Add them together. That is this with this. Let me pick another pen. This with this. I to I. J to J. Then K to K. So that's why I marked the two together. Then plus 8j minus 1 all over 2j plus 6k minus 3k. So when you add this together, what do you have here? You have negative 2 over 3 minus 1 all over 6. 6 is common. You have 3. This is 2. 2 multiplied by 2 minus 4 minus 1. 1 times 1, 1. Minus 5 over 6. This is minus 5 over 6i. Then let's look at the j. You have 8 over 1 minus 1 all over 2. 2 here. How many 2? 1 is here. 2. 2 times 6. 2 times 8, 16. Minus 1. This will be what? Plus 15 over 2.
Over 2.
And
15 over 2.
plus what?
3k.
3K.
Plus 3k. So that is what they asked us to do. So let's look at some of the applications that we've been saying in our book, and you've been asking yourself, how do we solve this one now? You will see how you solve it. And after the class, please lay your hands on those questions and solve them. Okay, let's look at the acceleration problem. The acceleration of a particle at any time t greater or equals to 0 t greater or equals to 0 is given by A equals to acceleration equals to differentiation of volume dv dt. Don't forget, acceleration is to differentiate the volume, right? So to differentiate the velocity rather, is the same thing as where we have 12 cos t cos 2ti minus 8 sin 2tj minus plus 16 tk. If the velocity v and displacement r are 0, at t, find v velocity and r at time, at any time, at any time. So let's look at the solution for this. As we all know that when you have dv dt, when you integrate dv dt, it will give you v. That is, integration is anti-differentiation. So now we have v. So our v means if we have,
Sorry, sir. Our DVDT will give us A, not V, sir.
will give us what?
Acceleration A, sir. Not V, sir.
No, come again. I didn't get what you are saying.
Sir, on the solution, I saw you write DVDT equals to V. I say it should be A, sir, not V, sir.
It should be A.
Yes, sir.
When I integrate V, what do you get?
Okay, sorry, sir. You are correct, sir.
Okay. Are we together now? So what we are saying here is integrating the other side, we're going to have integral of, let's say I, you want to deal with I first. It's going to be 12 cos 2t. Are we together?
Yes, sir.
dt minus, or let's say, okay, I can put minus there, j, because of the negative that is in the question, integral of, or let me just put positive here and put the negative inside, sine 2t plus integral of 16t squared, 16, which is k. Now, can we integrate this? What do we have? When you integrate this, what do you have? With respect to t.
We have
Remember,
minus,
12 in this case is like a
minus 12,
constant.
minus
Just take
24.
it out. 12 is out. Now integrate what is inside. Anytime you integrate 2t, cos 2t, what do you have?
Minus 2 sine 2t. Okay.
You have 1 over 2 sine 2t. Check your book. I
Yes, sir. Yes, sir.
plus, we have, when you integrate minus, you have, don't forget, this is minus 8. But when you integrate sine 2t now, I will have minus cos 2t. But in this case, I will have minus 1 over 2 cos 2t. So it's going to be this. Do you agree with me?
Yes, sir.
Only one person is talking, no?
Yes, sir, we agree with you, sir.
Okay.
Yes,
We agree, sir.
correct.
Cos 2t. J. Then, this is integration. So, when you now integrate the k plus 16t squared over 2k, everything is t plus c. Everything is what? Plus, let's say plus c1. We don't know the number, but let's look at it. Now let's get the final, the out of this. When you cut this one, this remains 6, this remains 4, this remains 8. Right. So we have it, v equals to 6 sine t 2t I plus 4 cos 2tj plus 8t squared k. Plus C1. Now, at the velocity, we want to put at any time t, we're talking about, let's say v equals to 0. When t equals to 0, what do we have? V equals to 0, when t equals to 0, what do we have? Then we can put 0, 0 equals to 6 sine 2 of 0 I plus 4 cos 2 of 0 j plus 8 t squared of 0 rather k plus c1. Remember, we are looking for that c1, the constant value. So this entire one will be what? 0 equals to 0 I plus 4 cos 0 is 1. So you have it to be 1j plus 0 plus c1. So our c1 is equals to minus 4j. Do you agree with me?
Yes, sir.
Because on the normal day, C1 supposed to be carrying negative, but when you multiply through, you have, it returns to positive. Now, our equation 1, or, okay, let me call this one, let's put this one to be equation 1. Let's call this one that we've ratified. Call this one equation 1. Sorry. Let's call this one equation 1 instead of the one of on top. You know, we've already simplified this one, call it equation 1. Then we have our V now to be equals to, our V now equals to 6 sine 2t I plus what? 4 cos 2tj plus 8t squared k plus negative 4j. So we can match the j together by saying our v equals to 6 sine 2t I plus 4 cos 2t minus 4 or j plus 8t square k. Now, is that the final answer? No. So now we go back to the equation. Remember the question says, find the one of V and R. So that for us to find the R now, how do we find R? It said, the R will be the R dt. Will now equals to the R dt will equals to the same equation that we are using. Six sine 2t I plus 4 cos 2t minus 4j plus 8t squared k. Now, how do we write? We can integrate. When you integrate both sides, what happens? When you integrate this side, you integrate this side, this one will be what? When I say integrate both sides, it simply means that you already cross multiply to the other side. It simply means that you only have integral of the R to be equals to integral of everything here, sine 2t I plus 4 cos 2tj plus 8t squared k, everything dt. That's the meaning. That's the meaning when you integrate both sides, right? So in this case now, we have R here. Remember, anytime you have the R with integral, the R d will go, that is differentiation aspect of it will be neutralized by integration sign. That was what I did the other time. So here now we do it component by component in order to be safe. I will come here. We have 6 sine 2t I sine 2t, since with dt, plus integral of 4 cos 2t minus 4. This is j dt plus, okay, I think this place can k integral of 8t squared dt. So we can begin to integrate this one. When you integrate it, how do you solve this one? You and I know that. Let me just do something here so that it will make our journey simple. You know, we have 6. I'll still come back to the integration. 6 is out, but when you are integrating what is inside, what do you have? You have minus 1 all over 2 cos 2t, right? Are we together?
Yes, sir.
Hello? People are far away. Hello?
We are together, sir.
We are together, sir.
Yes, sir, we are together, sir.
So what do we have? When you integrate that? If we are together, please tell us.
Which one are we integrating?
We are integrating
in its technical area, to stop this tactically.
Please,
Everything-
Mr. Football, let's hear word.
You might have to do this.
Which one we are integrating? Who can tell us?
We're moving to J now.
We are moving to J. Thank you. So, no, the first one, what do we have at the end of the day?
We have
We
in
have
the first
negative 3
3.
cos 2ti. Am I right?
Yes, sir.
Oh, okay. So I can now substitute it here. So what is J will be? Our J will be what?
J will be, we'll factor the 4 out. We'll have 1 over 2 sine 2t minus t, sir, by factoring 4 out.
No, if you don't factor the 4 out, what do you have?
Okay, if I don't have factor the 4 out, I'll have 2 sine 2t minus 4t.
Good. So let's just do it that way. So we have the first one will be minus 3 cos 2ti. The next one will be plus what?
Plus 4t, sir. So, no, sorry,
2 sine
2
t
sine
minus 4t
minus 4t, sir.
j plus 8 over 3 t cube plus c2. Let's call this one c2. Since we have c1 up. But in this case now, at r equals to 0 and t equals to 0, what do we have? We are going to have minus 3 cos 2 of 0i plus 2 sine 2 of 0 minus 4 of 0 j plus 8 of t, 8 over 3 of 0 plus c squared, c2. So cos this one will give me minus 3i, do you agree with me? Plus 0j plus 0k plus c 2. Then our c2 will be 3i. Do you agree?
Yes, sir.
Yes. Now, if C2 is 3i, what happened to equation? Let's call this one equation 2. Equation 2, what happened to equation 2? Equation 2 becomes what? We can now substitute it into equation 2 by saying our R equals to three minus 3 cos 2ti, because I've already marked all the c together, plus 2 sine 2t minus 4t j plus 8 over 3 t cube. That is what it asks us to do. So when you are given booklets that day, you know what you write. You know how it goes. Any question? Today we are able to cover the factor integral, and we are able to solve our call. We talk about surface integral, volume integral. We'll do more example on this as time goes on. We'll do more example, and I want you guys to try as much as possible to lay your hands on some of those problems, as many you can lay your hands on, and solve them. And at the end of the day, your exam will just be a walk away where you get to exam, or because you already have idea of what to do. Any question, please?